In this video, we'll be learning about how to solve logarithmic equations. So the first thing to talk about is what's a logarithmic equation. It's an equation with a logarithm on one or both sides. Typically, the variable is on the inside of that logarithm. An example of that would be log base 2 of x equals 3. So we've got to figure out how to solve for that x, how to figure out log base 2 of something to equal 3. So I think about it this way. First thing I want to do is get the logarithm all by itself. So if there are things added or subtracted to it, maybe multiplied or divided, somehow get rid of those first. Second is convert this to exponential form. And then the last thing we would do is solve for x. So on this one to convert, well, the log is already by itself. There's no addition or subtraction or anything like that. So the second thing I would do is convert this to exponential form. So when I convert, I always start with the base. On this one, the base is 2, so it would be 2 raised to the third power, and it always equals whatever's inside the logarithm. So 2 to the third equals x, or 2 to the third is 8, would equal x. So that's how I would solve that logarithm. In this example, to solve for this logarithm, it's log base 10 of 2x equals 3. First thing I always want to try to do is get the log by itself. That means that there's no addition or subtraction on the outside of the log, and that's already done here. Now, if there is no number written in the base, it's automatically base 10. So if you want to write that in there, you certainly can. You can write that as a base 10 right there. So the second step is convert this to exponential form. I always start with that base. The base is 10, and I'll raise that to the third power. And then this equals whatever's on the inside of that logarithm. So this will equal 2x. So we just figure out what that 10 to the third is. You can put that on your calculator or know that it's 1,000. There'll be 3 zeros for this one, equals 2x. And then we just do step 3 there, solve for x. So get the x by itself. However, you have to do that on this one. We just divide by 2 on both sides. And so 500 would equal x. If you want to take a minute and pause this video and give this one a try on your own, that'd be great. I'll give you the answer in just a couple seconds. So the answer for this one should have been 12. So in this example, we're going to solve this logarithmic equation. We got a little bit more stuff on the inside of this log. We have 4x minus 3 inside that logarithm. We'll deal with that at the end. That'll come in step 3. So the first thing I always want to do is get the log by itself. Once again, no addition or subtraction on this one. So we're just going to go ahead and convert this logarithm to exponential form. So start with the base. The base is 4, so we're going to raise 4 to the third power. And then that equals the argument, or whatever is on the inside of that log. So this will equal 4x minus 3. Once you've converted it, go ahead and solve for x. So we're going to figure out what that 4 to the third power is. 4 times 4, that'd be 16, times another 4, that is 64. So 64 would equal 4x minus 3. And then we solve that by adding 3 on both sides. And we get 67 equals 4x. And then we'll just divide both sides by 4. So divide both sides by 4. And if you want to put that on your calculator, you can. So 67 divided by 4. Let's go ahead and throw that over here. 67 divided by 4. And I get 16.75. So that's what x would equal, 16.75. And if you could pause that video, I'd like you to try this one on your own, and I'll give you the answer in a minute. And the answer you should have gotten is 1.45. In this example, we have logarithms on both sides, so we have more than one logarithm. So one way to do it, if we have equal logarithms, is first make sure the bases are the same. These are both base 5. If they are, you can set the arguments, it's a fancy way of saying the inside of the logarithm, you can set those equal to each other. So the way I visually see this is they're both log base 5, and so if I throw a little extra set of parentheses here, the inside of this logarithm and the inside of this logarithm need to be equal. They need to be the same value for this equation to be true. So if they're the same base, you can set the inside or the arguments of the logs equal to each other. That means that x minus 6 would have to equal 7. The inside of each log equals each other. Once you do that, just solve for x, and then you're good to go. So on this one, all we have to do is add 6 to both sides, and that would give me x equals 13. Of course, we can double check that. If I plug 13 back in for x, I see I get log base 5 of 7 equals log base 5 of 7. And if you could pause this video and try this one on your own, I'll give you the answer in a minute. And the answer you should have gotten for this is x equals 6. So on this problem, we're trying to solve for x. We have logarithms on both sides. So we got to make sure that the bases are equal to each other. If they are, we can set the arguments or the insides equal to each other. So they're both base 10 because there is no base written on there. If you want to write the base 10 there, you certainly can. But we are just going to set the insides of those logs equal to each other. That means that x squared minus x would have to equal 6. This one is not a linear equation. It's actually a quadratic. It's a little tougher to solve. To solve this, you have to factor. In order to find the factors, you always want to make sure it equals 0. So we're actually going to slide this 6 on the other side. We're going to subtract 6 on both sides before we do anything. So we would have x squared minus x minus 6 equals 0. Now to factor, we're looking for what two numbers multiply to give me this weird trinomial. So we're going to write this as two parenthesis groups. And to get the first term of x squared, we would have to have an x and an x in the front. If I were to FOIL this out or distribute, x times x gives me the x squared. So here's where you got to do a little bit of guess and check. Whatever numbers you put in the last spots, they have to multiply to that last number. They have to multiply to 6. So I'm going to think about, all right, all the factors of negative 6 off on the side. That could be negative 1 and 6, or negative 6 and 1, or negative 3 and 2, or negative 2 and 3. Those are all of my options. So I'm looking for which ones of those add to this negative 1, which is the number right in front of that x right there. And so the two that work for this one would be negative 3 and positive 2. So those are my factors that go in here, x minus 3 and then x plus 2. If you FOILed that out, you would get the trinomial right above it. So to solve that for equaling 0, x would have to equal 3 and x would have to equal negative 2. You, of course, could check those answers by plugging those in. I'm going to go ahead and plug in a 3 real quick in for all the x's on the top here and just see what that gives me. So it would be log of 3 squared minus 3. And 3 squared is 9, so this would be log of 9 minus 3, which is log of 6. So that does equal that equation right there. I'd like you to pause this video and try this one on your own. I'll give you the answer in just a second. The answer you should have gotten was x equals negative 5 and 1.